Yes, thanks again everyone for joining us here for today's Tech Talk, getting started with AWS Lambda and serverless computing. Again, my name is Chris Munz. I'm a principal developer advocate for serverless here at AWS. I've been at AWS now for a little over 7 years across a couple different roles, and for the last 2.5 years or so have been building and running a team of folks that are focused on helping our customers and developers understand what serverless computing is, how you can use it, best practices, patterns, and stuff like that. But I actually come from a little bit more of a, I guess we consider today a DevOps background, working for a number of startups in the New York City area. So enough about me. Why are we here today? Well, this topic of serverless is growing very rapidly in the industry. AWS first announced the core product we're going to talk about here today, AWS Lambda, back at our yearly developer conference called reInvent back in 2014. And since then, we've seen serverless grow again across all sorts of industries, all sorts of companies, verticals of different sizes around the globe. And today, serverless is probably one of the hottest topics that we see talked about. But what exactly is serverless? Now, here at AWS, we have kind of an official criteria that we put in place for how we qualify what is serverless and what isn't. So there's kind of 4 guiding principles. The first is that there's no infrastructure provisioning or no management, no cluster management or anything like that that you should have to think about. So no operating systems, no operating system patches or anything like that. The second is that as requests or as demand increases on your application, it should automatically scale to be able to handle that. Now, this is a very kind of common core aspect to cloud computing. But I would say one different thing about serverless is that we don't want you to ever have to think about the knobs or levers that would be required in this automatic scaling. It should just happen automatically for you. Another criteria that we have is called pay for value. We sometimes call this not paying for idle. And generally speaking, the idea here is that when we look at enterprise organizations and even most organizations with traditional IT infrastructure, a lot of the cost that they have for their resources actually goes to waste. And so when you have resources that are spun up, just sitting there in the background, you may not actually be using them or getting any value for that. And so with serverless, you're only paying for what you're using when you're using it. And as we talk through a number of the products here today, you'll see more and more about that. And then lastly, one of the core things that we try to do here at AWS as a whole is help reduce the burden on you for thinking about things like security and availability. And so with serverless products, that's no different. And so we have high availability and a number of security capabilities that are based across the portfolio of products, including many that we're going to talk about here today. And by default, I would say there's general best practices that are applied. And then we want to make it really easy for you to kind of take it a step further and secure things as right for your need. Now, those are kind of our 4 key criteria. But what is it that we actually hear customers saying serverless means to them? And we like to talk a lot about the benefits that you can't really easily explain, which is what we hear again from customers telling us. So the fact that they're able to have greater agility when it comes to building applications, deploying applications, iterating upon them, that they're focused on having much less operations, or I should say, because of there being much less operations, they have much greater product focus. When you remove all of the work that you'd be doing in managing physical infrastructure, or even infrastructure that's virtualized that involves operating systems, instances, scaling groups, cluster management, all of that, it's a lot of work. And so getting rid of that, again, allows the developer to focus more directly on their application. This should then align with a faster time to market. And again, based on the cost model and the scaling model, costs should grow with your business. And so what this means is whether you're an enterprise, whether you're a startup, you should be able to pay basically almost nothing to get started. And then as your business or your application grows in need and scale, your costs should automatically scale with that. So we're going to be focusing today primarily on one of the core products in this space again, which is called AWS Lambda. Now, AWS Lambda is a compute service at the end of the day. So yes, there are servers in serverless, but the idea here is that you should never have to think about them. That's something that's on the Lambda product team to build and maintain all of the infrastructure behind the scenes. And really, Lambda comes together in the center of a couple of different ideas. The first is this concept of event-driven compute. We'll talk a little bit about this in a couple different ways today, but it's basically, as we've seen developers move towards more of a microservices model, we find microservices being more fine-grained and kind of more drilled down into thinking about the event flows that exist inside of those microservices. Now that aligns very closely then with the idea of having functions that align to those events. So having single bits of code that can respond or be kind of correlated directly with individual events inside of a larger service. Putting all that together and then combining it with the criteria that we have for serverless, you get Lambda, which is a serverless functions as a service offering. And so again, basically behind the scenes, Lambda is going to maintain all of the infrastructure, all of the servers, and you just write your code. Now, Lambda actually handles quite a lot of things for you. Sometimes I see people just try to compare it to, a single EC2 instance or a single server somewhere, but Lambda is a lot more than just that. For example, Lambda is automatically handling for you load balancing, auto scaling, handling failures, security isolation, managing utilization, taking care of the operating systems, taking care of software packages and updates, and all that kind of good stuff. There's actually a lot of things that goes on behind the scenes that Lambda does for you. And so it's not fair to just say that it's a managed server, a managed instance, or even a managed container. There's a lot of things that Lambda does that helps make your life as a developer a lot easier. So when we talk about serverless applications built around AWS Lambda, again, what we have here kind of in the middle is a Lambda function. And so a Lambda function today can be composed in almost any language that you could think of that can run inside of a Linux environment. So Lambda functions today run Linux behind the scenes. So we have a number of languages that the Lambda service itself provides. So Node.js, Python, Java, C#, Go, and Ruby. And then we also have this capability called the Runtime API, which we launched late last year, which basically allows you to bring any language you could think of. And we have customers that have brought PHP, Swift, C++, Erlang, Elixir, all sorts of different languages. So if you go and you look on the various communities that are out there, there's a good chance that you could find the language you're looking for if you don't see what you're looking for here. So you take your Lambda function, and this is code that you write, you deploy it up to the service, and then you have to create a event source. And so today we have, I think, almost 50 different event sources at AWS that can directly invoke a Lambda function. And these represent across a number of different categories. So these could be things like changes in data state. So data records that are written potentially to a database, updated in some sort of a storage service. We have requests to endpoints. So we'll talk a little bit later here today about Amazon API Gateway, which allows you to build a serverless API. And so requests to that API Gateway endpoint will then go and invoke your Lambda function. And then we also have changes in resource state. And so across AWS, we have many developer and management tools, and pretty much almost all of them can invoke a Lambda function on your behalf. And so this allows you to create really interesting kind of automation inside of your infrastructure in response to developer events, whether it be CI and CD pipelines that you can build automation into, security governance and auditing, or responding to, say, failures or issues inside of your infrastructure. And then on the other side of this Lambda function is, well, basically anything that you want to connect your Lambda function to. This could be databases or data stores. This could be other API endpoints. This could be network calls that you need to make. Anything that you would typically be doing inside of an application running elsewhere could happen inside of Lambda as well. And so you've got all kinds of things that you could do, again, across these kind of three aspects of what makes up a serverless application built around Lambda. So let's actually step out here real quick and see what it looks like to build and launch a Lambda function. Okay, so I'm here in the AWS Management Console, and now I'm going to go over to the Lambda Service Console. So I click on Lambda, and I come here. And I'm going to click on Create a Function, and it's going to bring me to a dialog with a bunch of different options. And so we will call this basic function here webinar demo. In this case, I could see the various languages that are supported and their versions. And so I'm going to go with Python 3.7, and I'm going to click Create Function. And so now behind the scenes, this is going and it's going to pull together some sample code for me and establish some basic permissions for my Lambda function. We'll talk a little bit more about permissions here in a bit. And so it says up above here, it successfully created this function called webinar demo. I can actually go and test this here in a moment. Let's go ahead and look a little bit more at what's going on here. So we see in this window here, which is called the designer, that I have a Lambda function. It currently has no triggers or event sources. And on the right-hand side, where it says Amazon CloudWatch logs, these are basically the permissions or the other services that my function has permission to access. And so by default, Lambda will store logs for me. And so we'll talk a bit about this also a bit later. If I scroll down here, though, I see my sample code. And so really basic sample code, doesn't do anything too exciting. It's basically just going to give me a status code of 200, and it's going to print out a bunch of text here that says hello from Lambda. Let's go create a test event. And so events are passed in as JSON objects. And so I actually don't need anything here. So we'll just call this blank event and go and save it. Cool. So now I click test. And if I come up to the top here, I will see that my execution was successful. So, okay, what happened here? So I created a Lambda function, which created a bunch of code in a code artifact, and it defined the Lambda function as by the name webinar demo. And now when I click test, what actually happens is the event goes to the Lambda service. In this case, it was just an empty event, but it was targeted to this function by its name. And behind the scenes, the Lambda service had to go and find a compute resource. It had to pull down my code into that compute resource. It had to pull down the event into that compute resource, and then execute the code. And again, down here, the code that we see inside of my function is super, super basic. It basically just spits out a return. And so I could change this here real quick on the fly and say hello from the webinar. I can then click on save. And then once again, I can click on test. And so we see here that it has updated this output. So a really basic example, but let's take this one step further now. So let's close this output. Now let's go ahead and add a trigger. And so we've got a bunch of different trigger services that we can connect to this. You see a number of them listed here. We also have some third parties via a service called EventBridge, which is pretty cool, and we'll talk about this one later as well. Let's go ahead and just add an API gateway. And let's go ahead and create a new one. So we'll create a new API gateway endpoint. We're gonna leave the settings on this open for now, which typically you wouldn't want to do, but that's okay. The API name is called Webinar Demo API, and that's cool. The deployment stage we'll call dev, and we'll enable some metrics and logging. And again, there's a bunch of other options that we could go into, but we're just gonna go through this here quickly. Okay, so now it tells me that I have an API gateway, and it's configured as a trigger for my Lambda function. And now if I scroll down here, I see the API gateway endpoint. And so let me go now and open this up in a new tab. Okay, and so what you see here is I have my same text that we saw in the Lambda function presented right here in this window. And so what's now happened behind the scenes is I make a request to this public endpoint, which is now out on the internet, to my API gateway. And my API gateway is configured to have the Lambda function respond back to this endpoint. And so the Lambda function responds. And again, I can come back in here and I can change the text of my Lambda function. So let's do that real quickly. We'll say hello from the webinar, hello from the webinar API. And click save. And then if I come back up here to the browser and refresh this, the text is updated. Okay, so super basic example here of getting a Lambda function up and running. And again, what we've done is we have configured a Lambda function. We've played and tested the code out a little bit. We've then configured an API gateway endpoint and then made that available on the internet. Just here in a couple of minutes without having to do any installation of software, setting up any servers, setting up any networking, etc. Now we could do a much more complicated bit of work inside of this Lambda function. We could again connect to databases and data stores, but this is just to give you an example of how easy it is to dive into the console and get started. Okay, great. So you've seen here a brief example of a Lambda function. Now that Lambda function had a couple of different things going on. The first is what's called the handler function. So the handler is basically the main entry point into your code. It is what the service is going to execute and pass in your event. We'll talk about the event object here in a moment. And so again, in the case of this demo, I had a really, really basic Lambda handler. It took in the event and the context, and then it just spits out a status code and a body, which is a JSON structure that could be rendered in a browser. And so basically, again, the handler function is where your logic or the statements that call your logic would exist. Now we had an event object. I created just a blank JSON structure, just 2 brackets, but typically the event object is going to have a whole lot of information about what the event is. So if this was, again, an API request, it's actually going to pass in a whole bunch of other information about the API request that will come from API Gateway. And if I had an API that I was taking in some sort of information from, say from a browser, it would pass that in as well. And then the context object, which we really didn't interface with at all in this demo, contains a bunch of information about the actual environment that the Lambda function is running in, as well as things like the request ID, log information, timeout information, memory information. There's a bunch of things that it will get passed down. So these are kind of the three basic core things that you would see in a Lambda function. But we can extrapolate this a lot further. And so typically as a Lambda function grows, you have your handler, and then you will also typically have things like dependencies, configuration information, other helper functions. And in Lambda, any functions that you define before the handler can be executed ahead of time. So I had some pre-handler functions here that get called. And so those are kind of common helper functions. Maybe I'm connected to a database. Maybe I'm getting some sort of secrets or something like that. And then at the end here, I've got some other logic that I might want to execute. So maybe some independent business functions that do something with the data that's being passed in from my event. And so again, Lambda functions typically a lot more than just the handler, and even much more complicated than this over time. So let's talk a little bit more about how Lambda works. So as with almost all services here at AWS, there is an API that powers it. And so Lambda is no different. So basically, when you saw me invoke the function from the console and I clicked on test, that called the Lambda API. When I called my API gateway endpoint, that also, API gateway in this case, called the Lambda API. And so the Lambda API is basically the front door from any service that wants to call Lambda. There's no such concept as direct network access or say a port that you can connect to in order to invoke a Lambda API beyond the API itself. And so this is provided again by the Lambda service. It's used by all of the other models that exist out there, all the other services that are going to invoke Lambda. It supports asynchronous and asynchronous invocation model. We'll talk about that here soon. You can pass in any body of an event structure that you want. You saw me before, I passed in just an empty one. And what's cool is that, as with almost all of our APIs, the Lambda API is included in all of the AWS SDKs. And so you could just build your own applications to directly call Lambda without you having to think about having another service in front of it. And so many customers end up doing just that. Now, across the various models that we have here for Lambda, there's basically three execution models that exist. So the first is synchronous, or a push-based model. So in the example that we saw before, I had an Amazon API gateway. It invoked my Lambda function. My Lambda function then made a return call back to the API gateway, which then passed it up to my browser. So that is a synchronous model where the Lambda function is going to respond back to the calling service with some sort of data. We also have asynchronous events. So in the example of Amazon SNS, or Simple Notification Service, or Amazon S3, Simple Storage Service, we could have, say, a message that is put into an Amazon SNS topic, or an object put into an Amazon S3 bucket, and then those services go and invoke the Lambda function. But in the case of this situation, there's no request response that goes back to these services back up to the client. And so in this case, they just go and they invoke the Lambda function. The Lambda function does whatever it needs to do. And maybe your application is designed at some point to look at that other data or respond to it or what have you. And so in this case, this is an asynchronous model. And then last, for services like Amazon DynamoDB, Amazon Kinesis Data Streams, Amazon SQS or Simple Queue Service, we have a stream or pull-based model. And in this model, basically the Lambda service runs a poller which will pull these services, so DynamoDB, Kinesis, or SQS, pull out the data or messages from them, and then process it inside of a function for you. And so you don't have to worry about running any sort of the pollers that would traditionally be used with these services. Now, I talked briefly before about the importance of security and how when I went and created my function, some security settings were created by default. With Lambda, there's basically two core concepts to security: function policies and the execution role. And so function policies are basically the things that allow your event sources to invoke your Lambda function. So when I created my API gateway, it went and updated the function policy and it said, this API gateway can invoke this Lambda function. And so for anything, including cross-account policies, this allows you to, again, say who can invoke a Lambda function or who maybe can't invoke a Lambda function. And I should say by default, it is a deny all. And then the execution role, this is the AWS IAM role that your function is using when it wants to talk to other services. So for example, if my Lambda function had been configured to pull data out of S3, or had been configured to read data or put data into DynamoDB, then I would have to have an execution role that allowed it to do that. And so this is where you can get really fine-grained in terms of defining the policies for what your function can talk to, including things like other AWS services and so forth. Now, Lambda has what I think is a very fine-grained pricing model. Basically, there's two kind of core things that you think about when you're paying for Lambda: the amount of compute time that your function runs, and then the amount of memory that your function's been configured for. And so based on this, you can figure out how much a function costs per execution. Now, if you notice here on the slide here, it mentions that we have a free tier. I think the free tier is actually pretty incredible. If you're just getting started with Lambda, you can do quite a lot in the free tier without ever going over it. And so it gives you 1 million requests and 400,000 gigabits per second of compute. Again, this is actually a lot of compute and a lot of requests. And this is a free tier that exists again for you for every AWS account. Now, talking and taking this just a little bit further here. So I mentioned that you are charged based on the memory your function consumes. Now, with Lambda functions, there's basically just one knob that you can tune for them, and it's the amount of memory that's available to your function. With Lambda, there's no configuring today the CPU or the storage or anything like that. It's just this amount of memory that you can tweak. And so when you tweak that amount of memory, though, it brings with it a proportional amount of CPU and networking capacity. So what this means basically is when you start at the base of 128 megabytes and you go up to 256, you also double the amount of CPU and the amount of network bandwidth that you have to your function. If we were then double that again and go up to 512, we would now be, again, basically 4 times the original CPU and network capacity. Now, it can be a little hard to know if your functions are, say, memory bound or CPU bound. But one thing that I find is that often customers have applications that are CPU bound and they're not aware of it. Now, again, when you turn that knob up, you get that benefit of more CPU. Let's take a little bit look at how impactful that can be. In this case, what we've done is we have a function which is purposely CPU bound. So we're going to, essentially in a Lambda function, if we calculated 1,000 times all the prime numbers that are less than 1 million, which this is a decent number of numbers here, and some pretty CPU intensive math. And then if we were to run this against 4 different memory configurations, so 128, 56, 512, and then 1024. And Lambda functions can go all the way up to 3 gigabytes. But in this case, we're just going to do for these 4 right here. Now, what we see based on the color coding here is that at 128 megabytes, it took 11.7 seconds and change for us to complete this Lambda function. And then at 1024, it took 1.46 seconds. So pretty massive difference. Then if we look at how the cost aligns with that, so sure, the lowest memory is the cheapest cost, but the highest memory, the cost isn't that much different. So we actually look at the difference between these. When you go from 128 to 1024, you shave off over 10 seconds, and it only costs you 0.00001 of a dollar. And so, depending on your need, depending on what you're trying to accomplish, you might care a lot more about the speed of execution, or you might care a little bit more about cost. But you do have that flexibility to decide which one is more important for you. But again, remember that turning up that memory knob gives you more CPU, and that could be really valuable for your application. And so you'll want to play with the different memory configurations and see which one performs the best for you. And we'll talk a little bit here at the end about how you can also measure this as well. So putting all of this stuff together, the various invoke models or event sources, all the different things that you can do with your functions, all the ways you can configure the security and permissions, the ability for you to tweak and tune the performance of these functions. What it means at the end of the day is that Lambda is a really, really flexible tool for doing almost anything that you could think about. And so we have a number of common use cases that we see customers building applications with Lambda for. The first is web applications. So whether you're powering just a static website, whether you have a more complex dynamic website, these are both really good common use cases for Lambda. We also see backends or internal microservices being built in Lambda. And so again, this could be stuff that exists just inside of an infrastructure, service-to-service communication, mobile backends, IoT or device-connected backends. Data processing is actually one of the most popular use cases for Lambda. So we have customers that are processing many thousands of records per second with Lambda doing the compute side of the processing of those messages, potentially taking those messages out of, say, Amazon Kinesis data streams or Amazon SQS. And so with data processing workloads, we see real-time, we see streaming, map-reduce batch. There's all sorts of tools out there that can help you with building workloads like this with Lambda. Chatbots, so chatbots becoming increasingly popular both inside and outside of organizations. I know some of my favorite internal tools at Amazon are becoming chatbots. And then I've also interfaced with customer support through third parties that are chatbots. And so chatbot's a great way, again, to communicate with people in a flexible way. Amazon Alexa. So if you happen to have a device that has my good friend Alexa inside of it, you can actually configure and build your own what's called Alexa skill and power it with Lambda. And the Alexa team says right in their documentation that Lambda is the best backend for Alexa skills. Aligns really well with the Alexa model and integrates really closely with that platform. And then lastly, IT automation. So whether we're talking again about things like security and governance or development or management tools, there's a lot of things that you can plug Lambda into that help make IT automation workloads that much easier. So I'm going to expand out here a little bit talking about some of the other products that we have in the space that make up the serverless portfolio here at AWS. The next probably biggest one that is in the space is Amazon API Gateway. And so as the name might sound, this is an API Gateway product. You use it to build, manage, and host and serve APIs. Now, you saw me do this really briefly before in the demo that I had where I was actually just accessing an API via a web page. But you can use API Gateway to build really, really complex and sophisticated APIs that could be, again, accessed by web apps or mobile apps or device apps or internal microservices as well. Now, API Gateway is itself a really flexible product. Obviously, you can connect to Lambda, which we're talking about here today, but it can also be backended by things like traditional EC2 instances, by containers, by other AWS services, which is pretty cool. So you can actually put API Gateway directly in front of, say, something like DynamoDB. You could also put API Gateway in front of endpoints that are not inside of AWS. So if you have an API that's running, say, in another cloud or on premises, you could put API Gateway in front of it, both in a public and private sense. So really flexible product, lots of things that you could plug into it. We actually right now have a Twitch series called Building Happy APIs, which you can find on twitch.tv/AWS. And we were regularly every couple of weeks having a new episode there. It's all about APIs, and it's a really fun series. Now, in terms of how those APIs can be served up, I mentioned this a little bit here. We have three kind of core concepts here. We have edge optimized APIs. So these are APIs that are meant for mobile and web workloads where they are fronted by a content delivery network, in this case, AWS's CloudFront CDN. We support a concept called regional. So regional APIs exist just inside of an AWS region, and they are publicly available on the internet as well, in this case without a CDN. And so this is good for any sort of public service to service communication that you might need to have, potentially with third parties in that same region, or if you wanted to bring your own or a different CDN to put in front of your API. And then lastly, we also support private APIs. So these are APIs that run inside of an Amazon VPC, or virtual private cloud. And again, all sorts of use cases for this, from internal microservices to fronting an API that might live in a data center that you manage someplace else. Pretty flexible to plug it into lots of different things. And what we see people building with this is what I think is one of the biggest things in the future here of the industry, which is serverless web applications. And so today, with the newer JavaScript frameworks like React and Vue and Angular and some of the other ones that are coming out, You could have a static or single page app that is stored in, say, something like Amazon S3 or Amplify Console, which is another service that we have for hosting websites. That can then be fronted by, say, a CDN like CloudFront. Then you can have all of your dynamic data served out via, say, Amazon API Gateway and Lambda in front of whatever data store you might have and highly available through there. And if you look at all of these services, all of these are pay for what you use. They don't require you to run any infrastructure, set up any servers, install any software on them, have to think about high availability or anything like that. And so this is a completely pay for what you use model without having to manage the resources at a very high scale. And so we've seen customers take more traditional, say, N-tier web applications, reimagine them for this new world, and right away be able to reap the benefits of that. Now, there are a couple other architectures that exist out there that are also really common. I've talked a little bit about some of them so far today. The first is with Amazon S3 or Simple Storage Service. You can put objects into an S3 bucket and have that S3 bucket then automatically invoke a Lambda function. The Lambda function gets the information about the bucket name and the object and the action that was taken on it. And then it could potentially download that object, pass it into other AWS services like Recognition or Comprehend or Transcribe, and perform further actions on there. I've also talked a little bit about Amazon SNS or Simple Notification Service. And so as data is published into SNS, it can then go and invoke a Lambda function. SNS supports really interesting capabilities about being able to fork or fan out messages. And so you could use it as a way to pass messages to multiple Lambda functions that are doing different things. We'll also talk a little bit about Amazon SQS or Simple Queue Service. And so as messages are put into a queue, Lambda will be polling that queue and has the ability to then pull those messages out and execute upon them. Just a couple others here. So Amazon Kinesis Data Streams. It's a service meant for near real-time streaming of data at really, really high, I would say, velocity. So a lot of data. And what happens here is that you publish data into Kinesis. This could be things like clickstream data, sensor data, market data, log data, all sorts of data points that you might want to collect. AWS Lambda service runs a poller that pulls the data out of Kinesis, passes it into a Lambda function, and then that can execute your business code as well. Chatbots, so we talked about how chatbots are growing quickly and show up all over the place. And so Amazon Lex is a natural language processing service that we have at AWS that allows you to build chatbots. And these can be really interesting conversational chatbots. And then on the fulfillment side, or basically when your chatbot is ready for it to execute an action, then it can invoke a Lambda function. And so, putting these all together, you can again build really interesting serverless chatbots that can be used for pretty much any use case you could think of. And then lastly, this is one that I always like to talk about, and it actually kind of goes back to my own previous background where I have maintained infrastructures and run servers for a long time. And I used to have to maintain cron jobs. Cron jobs show up all over the place, some sort of scheduled task. And so here at AWS, we have a service called CloudWatch Events, which supports a scheduled event concept. And it actually matches the same kind of syntax as cron does. And then that can be used to invoke a Lambda function. And so that Lambda function can then do whatever it is that you need it to do. It also has the ability to call another service that we have, which is called run command at AWS. And as the name sounds, run command allows you to execute commands on EC2 instances, or actually servers that might be running anywhere, and for both Linux and Windows. And so you could very easily replace an existing cron setup with something like this. Okay, let's talk a little bit more about some of the rest of the serverless portfolio that exists out here today. When we talk about Lambda functions, we talk about you trying to focus just on your business logic and the actions that your code needs to take. And so one key kind of thing to think about is how you can keep orchestration out of your code. And so in order to do that, we have a service here called AWS Step Functions. It's another part of the serverless family here. And so what Step Functions allows you to do is it allows you to take all of your workflow logic, all of the things around like failure and retry, parallelization, the ability to do exponential backoff and retry, decision trees, all that type of stuff that maybe you would write, complicated if-else statements or switch statements in your code can go up to step functions. And so we see an example here of a step functions workflow where I'm going to extract some image metadata, and then based on the type of metadata that comes out of it, I'm going to do a type check. And if it's a supported image, then I'm going to store that metadata. I'm going to run recognition. I'm going to resize the image at the same time. I'm going to add the tags then to the metadata, and then the process ends. And now I could have even more complexity here. As you see, there's a failure capture for a not supported image type. And there's a lot of different things that I could do off of this. Now, Step Functions actually integrates with a number of other services besides Lambda. And so we could actually integrate directly with SNS and SQS, with SageMaker, which is a machine learning technology, with Glue and Batch, which can help you with things like ETL and batch computing, and then with Amazon Elastic Container Service and AWS Fargate, two container-based offerings that we have here at AWS. So a lot of things you can do with Step Functions. Really cool to take, again, your business logic and pull it out of your code, or say the workflow logic out of your code, so that your code is just your business logic. And that's what we think is kind of the best way forward. An example of, again, just kind of like what you can do when putting all of this together. And apologies here, it looks like my slide cut off some of the text. But so if we had to have, say, a polling solution to check on a job, you see the much more complicated workflow on the left-hand side. But now, since we have these integrations with services like Batch, we can actually have a workflow that has no code written by a developer. So we can have Step Functions kick off a batch job, and then after that batch job is completed, we can then have a message put off to SNS, and then that could be captured by someplace else. Or if there was an error, we could publish that error. And so again, we could do this without having to run any code to pull for the job to complete or to look for anything and then push out that message. So again, with Step Functions, you should be writing even less code. And then I'll round up here with the newest member of the serverless portfolio here at AWS, which is Amazon EventBridge. And so we just announced Amazon EventBridge here in the second week of July, so just a little while ago here. And what Amazon EventBridge does is it provides a really interesting capability for doing basically point-to-point integrations between different services. So this is a serverless event bridge, or sorry, a serverless event bus, I should say, for passing messages and events between different services. Again, it's part of the serverless portfolio, so it is completely managed. It's pay-as-you-go, has a lot of integration with AWS services, as well as a number of third-party SaaS applications that we integrated with, or I should say that we launched with. It has a really straightforward programming model. So in terms of how EventBridge works, there's a concept of event sources, and then you have the event bus or buses, you have rules to filter, and then you have targets. Today, over 90 different AWS services can be used as an EventBridge source. You can also write your own really easily with the Events API. In terms of targets, there are 17 targets that are today integrated into EventBridge. These are services like Lambda, like Kinesis, like SNS, like SQS. Pricing as well is pretty flexible. So it's $1 per million events that are put into a bus, and it doesn't cost any money for events to come out. And so it's common for you to have events go out to multiple targets. And in this case, you don't pay per target or anything like that. Now, EventBridge is actually built upon technology that existed for CloudWatch events. And so CloudWatch events has supported the same concept of Event Bus since it first launched. CloudWatch events today handles trillions of messages per month. So it's got quite a lot of capability in terms of being able to scale and handle every kind of traffic you're going to throw at it. It will durably store messages for you and then attempt to retry reaching out to targets for up to 24 hours. So if there is a service outage or an issue with your functions or something else that might be downstream from an event bus, it will be able to retry that for you. Like almost everything else at AWS, it's secured by IAM, or AWS Identity Access Management. Much like with Lambda, the event payload is JSON-based, and so there's no schema that you are forced into. And then, as I mentioned earlier, it's a really, really straightforward service to work with. You can just use the AWS SDKs, call the event put call or API call, and that's all that it is. You don't have to do anything else more complicated than that. It's really just a couple lines of code, and you're able to put events into EventBridge. So what are the kind of common things that you could do with EventBridge? So some common use cases here, we could take an event from, say, a SaaS application, put it into EventBridge, and have that trigger a Lambda function. And we launched again with a number of AWS partners, for example, like Datadog, like Zendesk, and so they have events that they can send into EventBridge. We could take EventBridge and send off an event to a step function. And so a step function, which can then go on and execute a more complicated workflow of business logic. We could apply machine learning services. So we could take in an event, we could send it to Lambda and have Lambda, say, pull out data that should go into Amazon Comprehend and then run, say, a machine learning job against it using SageMaker. And again, all of this without having to manage any servers, without having to think about scale or capacity. We can also take this data and throw it into Amazon Kinesis Data Firehose, which can then store it into S3, which can then make it available for you to query it using Amazon Athena or Amazon QuickSight, which is a business intelligence service. And Athena allows you to query data in S3. And so basically you can take all of these events, store them in S3 long-term, and then again, have the ability to do rich querying and analytics on top of it. And then lastly, we could just do something like have a Lambda function executed off the EventBridge event, which says, hey, pull data out of the SaaS application and then store it in DynamoDB. Now, I'm showing all of these as one-offs, but realistically, what you would be doing is typically you would have an event go to multiple targets. So imagine all 5 of these different use cases consuming a single event and then doing whatever activity that it needs to do off of it. Again, that's kind of the concept here with EventBridge, is that you would have the ability to more or less fan out to all of these different target endpoints to do whatever the various things are that you might need to for an event. Another way to think about it is in a traditional microservices model, there's typically some need to fan out requests. So let's say that we had a shopping cart or an ordering service. That ordering service then, when an order is processed, needs to send on information to, say, a fulfillment service, a credit card charging service, an inventory service, and so on. Many of those services would then potentially need to talk to other services or talk to each other or talk back to the order service to get more information. And so you see eventually complexity quickly creeps into our application. With EventBridge, what we could do is have the order service send a message to EventBridge. And then we could have all of the other services basically listening for the specific events that are important to them off of EventBridge. They could also then communicate back to EventBridge to share updates or other aspects of events back to other services. And so basically, again, EventBridge here provides a really flexible communication channel between various different services that might be running inside of your infrastructure. Now, almost all of the services that we've talked here today are covered by HIPAA and PCI. EventBridge, I think, is too new to be covered under these just yet, but we always try to work and get these covered here in the future. But things like Lambda, API Gateway, Kinesis Data Streams, Step Functions, SNS, SQS, CloudFront, these are all today covered under these. So if you do have to build an application for a more regulated workload or industry, you can do that with this. Cool. So we've talked a lot about a bunch of the services. We've talked about a number of their capabilities and what they can do. Where do you actually start? Now, you saw me log into the Lambda console before and quickly create a function, and that is one great way to do it. But personally, I like to recommend that people start with a framework. So there are a number of different third-party frameworks, as well as AWS frameworks that exist out there. From the third-party side, there are things like the Serverless framework, Claudia.js, Sparta, Zappa, Architect, Apex, a number of others that can help make it really easy for you to build and launch serverless applications. On AWS, we have a number here as well, and I'm going to talk to you a little bit more in depth about one called AWS SAM. Now, AWS SAM, or Serverless Application Models, is a template-driven capability that allows you to build and manage serverless applications. This is an extension that's built on top of AWS CloudFormation, which is a service that's been around AWS here for quite some time. And so with it, you create a template. That template basically defines the resources that you want to launch and manage. And for SAM, we have a couple of special resources, such as functions, APIs, simple tables, layers, and applications. Now, because it's built on top of CloudFormation, it supports pretty much anything that CloudFormation supports. And then the entire ecosystem around SAM is actually open source. And so you can find out more about SAM if you go to the link you see here at the bottom of the slide, https://aws to amazon.com/serverless/SAM, including links to the GitHub repository where you can find the source code for SAM, and I'd say a really robust open source community built around it. This is an example of a SAM template, and this is basically just 20 or so lines of code that at the end of the day creates a Lambda function, defines an IAM role, creates an API gateway endpoint, and then also creates a DynamoDB table, which can only be accessed by the policy defined here in this function. And so if we were to write this out in CloudFormation, it would be about 5 to 6 times the number of lines of code. And so again, SAM really simplifies the work involved in building, deploying, and managing serverless applications. Another way to think about it here, this is from another example that we have online, where if we look at lines 9 through 25, or roughly 10 through 25, what ends up getting created is about 7 different AWS resources. We've got a function, we've got API gateway, we have gateway deployment, we have permissions, and so forth. And again, if we were to write this in raw CloudFormation, it would make it be a whole lot more. Now, another part of the SAM ecosystem, I would say, is something called the AWS SAM CLI, or command line interface. And so the SAM CLI is a tool that you can run locally on your workstation, on your desktop, whether it be Windows, Mac, Linux, basically anywhere. You can install and run SAM. And so SAM has a whole bunch of cool capabilities. It gives you capabilities around local development, testing, debugging, deploying, managing your applications. It has the ability for you to fully emulate locally the Lambda environment that your function will run inside of. And then I also have the ability to have a mock API gateway or a mock Lambda service API. And so then I can test my functions no matter what the invoke source might be. I could pass in an event structure and it will execute it locally. Now it does this using a Docker image, which basically mimics the exact Lambda environment that we run on the Lambda service. And so again, you've got really close parity between what you'd be running locally and what you'd be running up in the cloud. So let's go real quick here and take a look at this. And I'm going to come back here to my console. In this case, I'm going to go over to a development environment that I have running in another service called AWS Cloud9. Now, Cloud9 is a managed IDE that AWS has, and it has a bunch of tools installed on it. So I can see here that I have the SAM CLI installed, and what I'm going to do is just create a new Python application. So it has now gone and created a new Python application. In this case, I called the init command to initialize that new project, and I'm going to create it in Python 2.7. Now the application has been created, and so what I can do is go into that directory for SAM app, and then I could tell SAM to include the dependencies for this application by running a SAM build. And so it has gone and created a new directory inside of this that has all of the dependencies that this application needs. This is a really, really basic application. I can then go into this directory and I can run SAM local. So if I run SAM local, start API, what it's now going to do is it's going to take my code, it's going to put it into a Docker image, and it's going to have that Docker container running again locally here on my laptop, or I should say in my Cloud9 environment. Now in here I have a SAM template. It's pretty straightforward. It basically just has a single function that's defined. There are some other capabilities in here such as globals and the outputs of the template file. But I see here that the API path is /hello. And so let me go here and kernel this. So running here on the local port at localhost :3000 /hello. And now this is actually going to start the environment and execute it. And so I see my output, which says hello world. Now, if I were to go and view my application source, what I see here is the message for hello world. And so I could say hello webinar, save this, and then come back in here and execute this again. And now we see hello webinar. So Really quickly, all that I've done is use the SAM CLI, which is already installed in my Cloud9 environment. I ran SAM init, which created a basic project for me. That basic project has a template file, which gets me started building an API-based workload. It has a really basic example. And again, SAM CLI supports all of the main languages that we have in Lambda. And so you can get started probably in a language that you're familiar with already today. Cool. So one other thing that SAM has allowed us to build is something called the AWS Serverless Application Repository. You can come in here and find hundreds of examples of serverless applications, see their SAM templates, see their source code, launch them in your account. And the Serverless App Repository is a great way for you to share both publicly and privately other applications. So I would definitely encourage you to check that out as well. Just want to finish up talking about how you can actually then go and do monitoring and logging and troubleshooting your applications. Now, we like to say that metrics and logging are a universal right with serverless applications. So across the serverless portfolio, we've got things like CloudWatch metrics and CloudWatch logs built in. Now, for Lambda and API Gateway, we capture a number of metrics just out the door when you launch a function or when you create an API Gateway endpoint. And so you see examples here with Lambda, the iterator age, DLQ, errors, concurrency. With API Gateway, things like 400s, 500s, API call count, and so forth. And so all this is made available to you, again, just by default. In terms of logging, very similar. So with API Gateway logging, we support different log levels. You can also optionally be able to capture entire request body. You can also create a custom log format. So there's quite a lot you can do with API Gateway logging. With Lambda logging, basically anything that you do that looks like a console.log or a print statement will automatically be captured by the Lambda service, sent to CloudWatch logs and made available to you. And so it's really easy for you to then dig up the logging data for your functions. Then once in CloudWatch logs, there are concepts around something called log pivots. This allows you to take individual data points out of a log line and create then a CloudWatch metric based upon it. Or if you want, you can export these logs to something like S3 or AWS Elasticache, or actually you can pump them into a Kinesis data stream and send them anywhere else that you want as well. So a lot of flexibility there. And then the last thing that I'll talk about here is AWS X-Ray. Now, AWS X-Ray is a profiling and troubleshooting tool that is integrated across the AWS kind of portfolio of serverless products. With Lambda and API Gateway, it's got some really deep integration. And so you can enable this in both Lambda and API Gateway and get traces of events as they happen through your application. In terms of what you need to do to make it work in your code, it's really easy. You see basically two lines that are highlighted in yellow on this slide here. I need to require the X-Ray SDK. And then if I want to capture AWS SDK calls, I just basically wrap the AWS SDK with the X-Ray capture AWS command. And basically from there, then I'll get all sorts of detailed information about calls to AWS services, the performance of them, if they fail, what errors might get captured, a whole lot of information from that. I can then also inside of X-Ray see trace, or basically a waterfall flow of what my function did and when and how long it took. And then there's a newer capability in X-Ray called analytics, which allows me to look at the entirety of an application flow, break down individual bits of information inside of it, potentially identify points in time where my application was performing less than ideal, or maybe there were increased in error rates or slowness or latency, and then be able to drill really deep into that specifically. Cool. So we've talked about a whole bunch of different things here today, hopefully getting you, some new information, some getting started guidance on Lambda. You could find out a whole lot more about all of these things at aws.amazon.com/serverless. Again, you can read more about Lambda, best practices. If you go up to the resources tab here, you'll see blog posts, other talks that we've done, white papers, case studies, all sorts of things, as well as links to the documentation for services like Lambda and API Gateway, Step Functions, EventBridge. And so you can really kind of dive in as well as getting started materials. Again, my name is Chris Munns. I'm a principal developer advocate for serverless at AWS. You can always reach out to me at munns@amazon.com. I'm happy to help you out. You can also reach out to @ChrisMunns on Twitter and ask questions there. I know we've had questions going on the side here. We're going to try to pick up a couple more, but I want to thank you for joining us here today and hope to see you at another Tech Talk soon. Take care.